In this video, we're going to talk specifically about arithmetic sequences. Arithmetic sequences are sequences in which each term changes by adding some constant d. So d can be positive or negative, so essentially we can add or subtract the same number over and over again. D is known as the common difference. And arithmetic sequences can be expressed both recursively and explicitly. Recall, the recursive formula relies on knowing the previous terms in the sequence to define the next term. So for a recursive formula, a sub 1 must be given to you. And then the next term, or the nth term, is the previous term plus some constant d. So a sub n equals a sub n minus 1 plus d. To write the explicit formula, we can find any arbitrary element in the sequence. Formula is a sub n equals a sub 1 plus n minus 1 times d. Okay, so let's take a look at a couple of examples. So we want to write this formula, the explicit and the recursive formulas for this sequence, and find the seventh term. So let's first find the recursive formula. So the recursive formula, a sub 1 must be given. So a sub 1 in this case is negative 5. This is the first term in the sequence. Okay, the next term, or the nth term, is the previous term plus d. So a sub 1, a sub n, is equal to a sub n minus 1 plus, okay, well now we need to find d. The way we can do that is take consecutive terms and subtract them. So 2 minus negative 5 is 7. We can take any two consecutive terms, so we could have taken these two terms as well. 9 minus 2 is 7. So in both cases, d is 7. So our formula is a sub n equals a sub n minus 1 plus 7. So this is the recursive formula. Let's use the recursive formula to find the seventh term. Well, we've got the first three terms, so to find the seventh term, I first need to find the fourth term. Well, the fourth term is equal to the third term, which is 9, plus 7, which is 16. Now I need to find the fifth term. Well, the fifth term is the fourth term, which is 16, plus 7, which is 23. Now I need to find the sixth term. The sixth term is the fifth term, which is 23, plus 7, which is 30. Now I can find the seventh term. The disadvantage of a recursive formula is you have to find every term in the sequence in order to find the next one. So the seventh term is the sixth term, which is 30, plus 7. And so the seventh term in the sequence is 37. So let's take a look at the explicit formula. The explicit formula, a sub n equals a sub 1 plus n minus 1 times d. So a sub n equals a sub 1, which is negative 5, plus n minus 1 times 7. We previously found that d was 7. Oops. Okay, that was easy enough. Now let's find the 7th term in the sequence. Well, we can just go ahead and plug in n equals 7 into this formula. And we'll find that this is 37. So we got the same answer that we got when we used the recursive formula. The explicit formula is much easier, however. All right, let's take a look at another one. Let's first find the recursive formula. So a sub 1 is given. That's 3x minus 1. A sub n is equal to a sub n minus 1 plus d. All right, so we need to find d. And to do that, we take consecutive terms and subtract them. So 5x minus 4 minus 3x minus 1. So 5x minus 3x is 2x. Oop, sorry, that was the end of the day bell. Negative 4 minus minus 1 is negative 3. Okay, so a sub n minus 1 plus 2x minus 3. So this is our recursive formula. Well, I don't want to find the 20th term using a recursive formula. So I'm going to use the explicit formula to find the 20th term. So let's find the explicit formula. That is going to be a sub n equals a sub 1, which is 3x minus 1, plus n minus 1 times d, which is 2x minus 3. So this is our explicit formula. Now let's find the 20th term in the sequence. And we'll just plug in 20 for n. Okay. So this is 19, and so we'll distribute the 19. And now we'll just combine the like terms. Oops, this is 38x. So that is 41x minus 58. In the next video, I'll talk about geometric sequences.